What if the universe is not silent at all, but only waiting for us to notice its smallest size? Imagine lying under a velvet sky, the stars flickering like scattered lanterns, when suddenly a single note rises out of the quiet so faint, so fleeting, that you could almost mistake it for your own heartbeat. 48 years ago, humanity heard such a note, a radio signal that lasted for exactly 72 seconds, strong enough to pierce the vast sea of static, precise enough to defy our expectations, and mysterious enough to change the way we think about the sky above us. Hey guys, tonight we're going to drift through this story together, one that begins with a whisper from the constellation Sagittarius and stretches all the way to the arrival of a visitor from beyond the stars. It's a journey of questions more than answers, of coincidences that may not be coincidences at all, and of how our species learns to listen when the universe decides to speak. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like sharing, post your location and your local time down below. It's always magical to see where in the world everyone is listening from. Now, if you're ready, let's begin. In the summer of 1977, while most of the world slept, a massive radio telescope in Ohio turned its ear toward the heavens. Known simply as Big Ear, it didn't look like the elegant satellite dishes you see in photographs. Instead, it resembled a long metallic trough carved into the earth, stretching out like a forgotten monument, waiting quietly for signals no one was sure would ever come. Its job was simple but monumental: to scan the skies for patterns in the radio spectrum, searching for any sign, however faint, that intelligence might exist beyond Earth. And then it happened. Out of the background murmur of the galaxy came a single burst of sound, though it wasn't something you could actually hear. It was written in numbers and letters, carved into a computer printout, the kind of data most people would overlook as meaningless noise. But this signal was different. Its frequency was narrow, impossibly precise, and right on the hydrogen line, that universal frequency that scientists had long speculated would be the best place for civilizations to communicate. Astronomer Jerry Eman circled the strange string of characters on the printout with a red pen and scribbled just one word in the margin: "Wow." That single exclamation has echoed for nearly half a century, not because of what we understood, but because of what we didn't. The signal appeared, burned bright for 72 seconds, and then vanished forever. No repetition, no explanation, just a whisper, and then silence. Think of it as if the night sky had leaned down for a moment, whispered a secret in our ear, and then retreated back into its infinite distance. Was it an accident, a cosmic coincidence, or the first syllable of a conversation we never quite learned how to answer? Sagittarius, the constellation from which the signal seemed to originate, is no ordinary patch of stars. When ancient people looked up, they saw the image of a centaur half human, half horse, drawing back his bow and pointing an arrow toward the center of the galaxy. They could not have known that their myth would align with modern science in such a haunting way. For when we gaze in that same direction today, we are looking into the crowded heart of the Milky Way, toward a supermassive black hole and a storm of stars so dense, so full of energy, that it is like staring into the beating heart of creation itself. The fact that the "wow" signal came from this region is both poetic and troubling. Poetic because it feels like a message from the very core of our cosmic home. Troubling because this is the noisiest neighborhood in the galaxy, full of radio waves, bursts, and interference. Imagine trying to hear a soft whistle in the middle of a roaring stadium. That is what astronomers face when they listen towards Sagittarius. And yet, the signal was so clear, so precise, that it stood out from the chaos like a single violin note cutting through a thunderstorm. But why hydrogen? Why 1,420 megahertz? Hydrogen is the simplest and most abundant element in the universe. It is the building block of stars, of planets, of water, of life itself. Scientists have long believed that if civilizations were to speak across the void, they would choose this frequency because it is universal, inevitable, and recognizable. It is like the cosmic equivalent of a meeting place that everyone, no matter their culture, would know. Picture it like this: a village square, where strangers come from all directions to meet, because it is the one place everyone can find. The hydrogen line is that square for the universe, and the wow signal arrived exactly on that line, as if someone, somewhere, had left us a message carved into the very physics of reality. Yet the story might have ended there, a single, unexplained anomaly, a puzzle to file away and occasionally revisit, until now. Because nearly half a century later, from that very same region of the sky, something else appeared. Not another radio whisper, but a moving point of light, steady and deliberate, carving its way into our solar system on a trajectory that no ordinary comet or asteroid could explain. They called it 3IATLAS, the third confirmed interstellar visitor to enter our neighborhood. The coincidence is staggering. Two mysteries, decades apart, both connected to Sagittarius, a signal from the stars and a traveler from between the stars. Was it chance, or were we warned? As you let these questions linger in your mind, imagine yourself lying back, feeling the weight of your body sink into the mattress, your breath slowing, your eyes heavy. The night outside continues in silence, but above you, far beyond the veil of atmosphere, the galaxy hums with energy and possibility. Perhaps the wow signal was nothing more than an accident, a natural emission mistaken for intention. Or perhaps it was the first line of a story we are only now learning to read. 3I divided by Atlas may hold answers, or it may deepen the mystery. But tonight, as you drift into rest, hold on to the image of that red ink on a printout, the single word scrawled in wonder. Wow. It was not proof, not certainty, but it was enough to remind us that the universe is still capable of surprising us, still capable of calling out when we least expect it. And maybe, just maybe, that whisper has been waiting for us all along. On the night of August 15th, 1977, while the United States was still humming with the echoes of summer, a quiet drama unfolded in the Ohio countryside. There, resting in fields of grass and surrounded by the ordinary sounds of crickets and distant traffic, stood a telescope unlike any you might picture. It had no elegant dish angled toward the heavens, no towering dome split open to reveal a mirror. Instead, the Big Ear telescope looked more like a massive trough carved into the land, two long reflective surfaces stretching across the earth, waiting for the sky to rotate overhead. This humble instrument was designed for patience, not spectacle. It could not swivel to chase a star, nor dart to catch a sudden flare. It simply stood still, letting the planet's rotation sweep the sky across its view. And it was during one such routine sweep, an ordinary turn of Earth beneath the heavens, that something extraordinary happened. At first, it was just data. The telescope did not ring bells or flash warning lights. The computers, primitive by today's standards, converted radio intensities into numbers and letters, printing them out in neat rows on continuous sheets of paper. Most of the time, those sheets showed nothing but the cosmic murmur ones and twos, the alphabet of silence. But on that August night, a sudden spike rose from the quiet. Letters and numbers climbed higher and higher, forming a perfect peak, then fell away in a mirror image of themselves. Days later, Jerry Eman, a volunteer astronomer, sat down to review the printouts. The room must have been unremarkable, lit by fluorescent bulbs, filled with the faint smell of paper and ink. He sifted through the stacks until his eyes caught on something unusual. 6 EQUJ 5, a sequence of characters that told of a burst 30 times stronger than the background. The shape of it, matched exactly what an astronomical signal should look like as the Earth's rotation carried the source across the telescope's beam. Jerry felt his pulse quicken. In that quiet office, history whispered. He picked up a red pen and circled the numbers, writing a single word in the margin. Wow! That word, dashed off without ceremony, would become one of the most famous annotations in the history of astronomy. Imagine him there, pausing with the pen still in hand. Did he smile? Did he feel a chill? Perhaps he wondered whether he had just stumbled onto the first proof that humanity was not alone. In that moment, he must have been aware of how fragile the evidence was. A signal on paper, a sequence of characters, nothing that could be replayed or heard again. And yet, the elegance of it, the sheer improbability, was enough to make him believe that something wondrous had brushed against us. The wow signal, as it would come to be called, was narrowband so precise that nature rarely produces it. It was centered almost exactly at 1,420 megahertz, the hydrogen line, the frequency every SETI scientist had whispered about in hope. And it had the intensity of a shout, not a whisper. For 72 seconds, the sky had spoken in a language no one could mistake for ordinary noise. And then, it was gone. Think of it like standing on a dark shore and seeing a lantern flare once across the water, bright, sharp, and purposeful. Then darkness again, leaving you to wonder if you had imagined it, if the light was real, or if it meant someone was out there calling back. Astronomers scrambled to follow up. Telescopes were turned toward Sagittarius, the patch of sky where the signal had appeared, but they found nothing. No repeat, no echo. It was as though someone had tapped on our window and vanished into the night. The frustration was as deep as the wonder. Science requires repetition, and this mystery refused to repeat itself. Yet the story of the wow signal endured. It inspired countless searches, fueled debates, and etched itself into culture. For many, that red ink wow became a symbol of humanity's longing, a reminder that sometimes the universe gives us just enough to keep the question alive. But let us slow down and picture the scene not as data and paper, but as something more human. Picture Jerry Eman alone at his desk. The clock ticks softly. Outside, night settles heavy on Ohio. His coffee has grown cold, the papers stacked high beside him. And then, on one page, he sees the anomaly. His brow furrows. He leans in, tracing the rising characters with his finger. And perhaps, in that moment, he feels not like a scientist cataloging data, but like a child finding a seashell from an ocean he never knew existed. That is the beauty of the wow signal. It is not proof. It is not certainty. It is possibility. And possibility is what keeps us listening, decade after decade, through static and silence. Sagittarius, again, is no ordinary place. It is the arrow pointing toward the Milky Way's heart. Ancient stories imagined it as a centaur archer, but modern astronomy reveals something even more astonishing. A gravitational storm, a black hole millions of times the mass of our sun, and an environment where stars are packed together like fireflies in a jar. To receive a signal from such a place feels almost poetic, as if the universe had chosen its most dramatic stage to deliver a fleeting performance. And so the wow signal became legend, not because we solved it, but because we didn't. Its unresolved nature lingers like a half-remembered dream. Was it a natural maser, a cosmic laser of hydrogen gas excited by some violent event? Was it interference from Earth, disguised as an interstellar message? Or was it truly what so many secretly hoped for, a deliberate signal, brief but intentional, sent across light years to say, "We are here"? Tonight, as you drift deeper into calm, let that thought settle with you, a red pen circling numbers on a page. a single word scrawled in wonder. Wow. Maybe it was nothing. Maybe it was everything. The truth remains just out of reach, like a star seen in the corner of your eye, vanishing when you look directly at it. But in that mystery lies a kind of comfort, because the wow signal reminds us that the universe still holds secrets, still holds the power to surprise us, and still has the ability to draw a whisper of awe from the human heart. As you breathe slowly now, feel yourself floating with that thought, rocked gently by the rhythm of your own pulse, as if it were echoing the faint pulse of that signal long ago. For in a way, every heartbeat is its own wow proof that something unlikely, something extraordinary, is happening right now within you. And perhaps, one day, the cosmos will circle our own signal and write its own word of astonishment in red ink. Imagine a vast library, each shelf stretching farther than the eye can see, each book humming with a different note. This library is the electromagnetic spectrum, the grand catalogue of frequencies that ripple across the cosmos. Some pages are loud and messy, full of static and storms. Others are hushed and nearly empty, spaces of quiet where even the universe seems to pause. Among those pages lies one line, precise and sacred, like a bookmark left by creation itself. 1420 megahertz, the hydrogen line. Hydrogen, the first element, is the universe's oldest storyteller. It was born moments after the Big Bang, when matter itself was young and simple. Every star you see, every planet you know, every drop of water you have ever touched is written in hydrogen's language. And hydrogen has a secret. Sometimes, in the depths of its quantum heart, its single electron flips its orientation, releasing the tiniest sigh of energy. That sigh radiates at 21 centimeters in wavelength, 1420 megahertz in frequency. It happens rarely for one atom once every 11 million years on average. But the universe is crowded with hydrogen. Clouds stretch across light years, oceans of atoms stacked upon oceans, and together their whispers form a constant background hum. That hum is universal. Any civilization with even modest radio technology would stumble across it, just as we did, and know they had found something fundamental. This is why scientists call the hydrogen line a beacon, a lighthouse of physics itself. It is not cultural, not biological, not tied to any particular world. It is written into the fabric of the cosmos, a note that every intelligent ear is destined to hear. Imagine two strangers from distant lands who share no language, yet both know the North Star. Hydrogen is that star, pointing the way across the gulf of the unknown. And so, when the wow signal appeared almost exactly on this frequency, astronomers felt a shiver of recognition. It was as though someone had dialed the universe's most obvious phone number. No need for translation, no chance of confusion. The signal arrived where it should arrive if anyone, anywhere, wanted to be heard. Early SETI pioneers predicted this. In 1959, Giuseppe Cocconi and Philip Morrison published a paper that essentially founded the modern search for extraterrestrial intelligence. Their logic was elegant. Any civilization discovering radio would eventually find the hydrogen line just as we did. If you wanted to leave a calling card, you would place it there, knowing it would not be missed. They even had a poetic name for the region around that frequency, the waterhole. Because hydrogen combines with hydroxyl to make water, the molecule essential for life as we know it. And what better metaphor? Across cultures and centuries, waterholes have been the gathering places of living beings. In deserts, they are oases. In forests, they are sanctuaries. To imagine civilizations meeting in the hydrogen waterhole is to picture the universe itself as a communal well where distant minds bend to drink. But the hydrogen line is not just symbolic. It is practical. Signals at this wavelength slip easily through clouds of gas and dust, traveling immense distances without being absorbed. They carry cleanly, requiring little energy, like a whisper that somehow manages to echo for miles. And many nations on Earth protect this frequency from interference, recognizing its importance for astronomy. To send a message here is to place it on the quietest street in a bustling city where it will not be drowned out. This universality raises a haunting thought. If the wow signal truly came from intelligence, then whoever sent it was not just reaching out blindly. They were using the exact channel we would expect, as if they had studied the same textbooks, followed the same reasoning, walked the same intellectual paths. It suggests a kinship across unimaginable distances, different worlds, different histories, yet the same physics guiding our thoughts. Still, hydrogen has its trickster side. Nature itself can mimic intelligence here. Hydrogen masers, cosmic radio lasers, can flare with incredible power when excited by violent events. Star-forming regions, collapsing clouds, even magnetar flares can produce narrowband emissions. In other words, the waterhole is not empty. It is both a meeting place and a masquerade, where nature sometimes puts on a costume and pretends to be deliberate. That is the dilemma. The same frequency that seems most logical for communication is also the one most prone to natural imposters. It is as if we are listening in a crowded tavern, straining to pick out one voice, only to find that echoes and chance rhythms mimic words we long to hear. Yet perhaps this is fitting. If the cosmos wished to challenge us, it could not have chosen better. To find another voice, we must listen with patience, humility, and discernment. We must accept that false alarms are part of the process. And we must remember that even when the voices prove natural, they still teach us something profound about the universe we share. So tonight, as you let your breath slow, think of that frequency 1420 megahertz as a kind of cosmic lullaby, a tone that is always playing, always surrounding us, carrying secrets from clouds of hydrogen drifting light years away. Imagine yourself tuned into it, not as a scientist straining over printouts, but as a dreamer, floating in a sea of invisible song. Perhaps one day we will discover that someone else, somewhere far away, is listening to that same frequency right now, wondering if they are alone. Perhaps they too have circled numbers on paper, or whispered, "Wow," into the silence. The hydrogen line is our common thread, a note that binds us to whoever else is out there, a reminder that across the immensity of space, we are all listening to the same universal music. And maybe, just maybe, that is the first step in learning how to answer. On July 1st, 2025, while most of the world slept beneath ordinary skies, an instrument in the Atacama Desert caught a glimmer of the extraordinary. The ATLAS survey system, designed not for glory, but for vigilance, had been scanning night after night for asteroids that might one day threaten Earth. Its cameras swept the heavens methodically, collecting millions of points of light, each catalogued and compared like beads in an endless rosary. But on that night, one point betrayed itself. It moved. Stars, steady in their ancient positions, are the fixed notes of the sky. Planets wander slowly, predictable in their cycles. But this object shifted against the backdrop at a pace too strange to ignore, neither star nor familiar asteroid. The algorithms flagged it, like a heartbeat skipping in a steady rhythm. Astronomers leaned closer. Its path screamed outsider. Not elliptical like a comet tied to the sun's leash, not circular like a planet's faithful orbit, but hyperbolic, open, unbound, a curve that enters once and never returns. They named it 3I divided by Atlas, the third confirmed interstellar visitor to our solar system. The I stood for interstellar, the mark of a traveler not born of our Sunday. And Atlas, the survey that discovered it, became the witness to this cosmic arrival. Imagine, for a moment, what that means. Our solar system is a quiet neighborhood compared to the sprawling city of the galaxy. For billions of years, it has circled the same star, its planets dancing the same choreographed orbits. Then, from the deep interstellar dark, something arrives, something that has spent eons wandering the gulfs between stars, carrying the dust and chemistry of a world we may never see. To detect such a visitor is like standing on a beach and finding a seashell from an ocean you never knew existed. The first such discovery came in 2017 with Oumuamua, a cigar-shaped enigma that slipped through too quickly for us to study. 2 years later came Borisov, a comet that behaved more like what we expected, but still departed before we could understand it fully. And now, 3IATLAS, our third chance, but also our most generous. Unlike its predecessors, this wanderer was discovered inbound, offering months of observation, a rare window to peer into the chemistry of another star system. Already, its strangeness announced itself. Early measurements suggested a body no larger than a few kilometers, across perhaps even smaller. Yet it was alive with activity, producing a coma and tail that dwarfed its modest size. Astronomers called it overperforming, as if it were an actor playing a role far beyond its build. The James Webb Space Telescope turned its eyes toward it and saw a chemistry that defied expectations. Carbon dioxide outshining water vapor by nearly 8-1. In our own solar system, water is the dominant breath of comets. Here, CO2 claimed the stage. Hubble added another puzzle: nickel emission lines, without corresponding iron, a duet where one singer had left the stage. Ground-based observatories confirmed the anomalies, each measurement adding weight to the mystery. Was this merely a comet from a hotter star system, forged under different rules, or was it something else entirely? The poetry of its path deepened the intrigue. 3I, divided by Atlas, was not just passing through, it was passing through from Sagittarius, the same celestial address as the wow signal. Coincidence, perhaps. But when coincidences pile atop one another, they begin to feel like patterns. 48 years ago, a whisper in radio. Today, a traveler in stone and ice. Both from the same direction, both defying easy explanation. It was enough to make even the most skeptical astronomer pause. Picture the Atacama Desert on the night of discovery. The air is thin, crisp, and dry. A place where the stars blaze with unusual clarity. A technician scrolls through images, thousands of dots scrolling past, then pause. A point of light is not where it should be. The sky has revealed a secret. Perhaps he leans back, breath caught in his throat, aware that something ancient and alien has just brushed against our solar system. Outside, the desert wind moves sand across the empty flats, as if erasing footprints. But above, the stars witness silently, as they always have. This is what makes 3I divided by Atlas so extraordinary. It is tangible. Unlike the fleeting wow signal, which left only ink on paper, this visitor can be tracked, measured, and studied. We can photograph its coma, analyze its gases, and follow its trajectory. It is not a ghost but a guest, however brief the visit, and yet, like the signal, it raises more questions than it answers. Is it a natural wanderer, ejected from some planetary nursery long ago? Is it merely a snowball carrying the quirks of an alien chemistry? Or could it be something more deliberate, a messenger disguised as ice, slipping between stars like a bottle tossed into an ocean? Speculation is easy, proof is hard. Scientists are careful not to leap beyond the evidence. But in the quiet hours, when the telescopes track the faint glow of this object against the velvet dark, it is hard not to wonder. As you breathe slowly now, let yourself imagine the journey of 3I divided by Atlas. Picture it drifting through interstellar space, silent and unlit. for millions of years. No star to warm it, no planet to greet it, only the endless night. Perhaps it passed near other suns, glimpsed other worlds, carried whispers of other chemistries. And then, by chance or by design, it bent toward our sun and found us waiting. It is humbling to realize that this fragment of another world has come so close. Humbling, too, to know that soon it will leave again, resuming its eternal voyage into the void. We are given only a fleeting encounter, a passing handshake across unimaginable distances. So, as you drift into stillness, let the image of 3IATLAS settle in your mind. A traveler from beyond the stars, luminous in the darkness, carrying questions we have not yet learned how to answer. Like the wow signal, it reminds us that the universe is not finished surprising us, not finished teaching us wonder. And as with all visitors, the most important thing is not just who they are, but that they came at all. Imagine two notes played on the same instrument, decades apart, yet resonating with uncanny harmony. One is faint, a fleeting whisper caught on a printout in 1977. The other is bright and tangible, a comet-like traveler entering our solar system in 2025. Both arrive from the same direction, Sagittarius, and both refuse to explain themselves fully. It is as if the universe has written us a melody in two parts, and we are only beginning to recognize the theme. The wow signal was a burst of radio energy that should not have existed, precise, narrow, powerful. It came once and never repeated. 3IATLAS is a piece of matter, a frozen remnant of another star system, defying the usual chemical balances we know. One signal was invisible, the other luminous. One lived for 72 seconds, the other for months. And yet, when placed side by side, they feel like echoes of each other, different forms of the same mystery, arriving almost exactly a human lifetime apart. Think about that span, 48 years. Long enough for a child to grow into an elder, long enough for technologies to evolve from bulky computers to satellites scanning the skies with unprecedented sensitivity, and perhaps long enough for the universe to finish a sentence. It began in 1977. Was the wow signal a prelude, a first word, and 3IATLAS the punctuation that followed? Or are we guilty of weaving meaning into coincidence, finding patterns where none were intended? Humans are pattern seekers by nature. It is what helped our ancestors survive, to notice the rustle in the grass, the shadow in the trees, the tracks that meant food or danger. That same instinct now drives us to stitch cosmic mysteries together, to see connection in the random. But sometimes the patterns are real. Let us picture the two events side by side. In 1977, in the quiet fields of Ohio, Jerry Eman circles 6 characters with a red pen. His hand trembles just slightly as he writes, "Wow," a note of astonishment destined to outlive him. Outside, the summer air is thick and warm. The telescope's metal surfaces gleam under the moonlight, indifferent to the history they have just recorded. Now, in 2025, high in the Atacama Desert, a modern telescope watches a new anomaly. The sky is cold and thin here, stars blazing like diamonds scattered across black velvet. On a computer screen, a single point of light slides against the background. Astronomers check the data again. It is real. An interstellar visitor is on its way. Separated by time and place, the two discoveries nonetheless speak across the decades, like voices calling through a canyon. You can almost imagine them bouncing off the walls of history, repeating not in sound, but in significance. What are the odds? In a universe of 2 trillion galaxies, in a galaxy of hundreds of billions of stars, what are the chances that 2 of the most perplexing anomalies in modern astronomy would come from the same celestial neighborhood? Statistically, coincidence cannot be ruled out. Sagittarius covers a vast patch of sky. To say both events point, There is a little like saying two mysteries both happened in the same city. The city is enormous, crowded, chaotic, and yet the details still whisper. The wow signal fell exactly on the hydrogen line, the cosmic frequency every civilization would know. 3I, divided by Atlas, carries chemistry that feels like it belongs to another set of rules entirely. Both events are unusual, both improbable. To have them aligned in direction and separated by less than a human lifetime stretches coincidence to its limit. Myth has always helped humans frame the incomprehensible. The ancient Greeks pictured Sagittarius as a centaur archer, drawing his bow toward the heart of the galaxy. Could it be that, through pure chance, we too are being aimed at by mysteries from that direction, one invisible, one material? Perhaps. Or perhaps mythology is simply our way of giving shape to chaos, clothing the unknown in familiar forms. Yet there is another story we might tell. Imagine the cosmos as a grand conversation, not rapid, not impatient, but spoken in the slow syllables of light and matter. In such a conversation, 72 seconds could be a word, and a 48-year wait could be a pause before the next. The wow signal and 3I, divided by Atlas, taken together, might be part of a message written in a language we do not yet understand. Speculative? Of course. But speculation is how wonder survives. What if the wow signal was a deliberate call? A beacon placed exactly where we were most likely to notice it? And what if 3I divided by Atlas was the follow-up, the physical messenger arriving on a trajectory calculated to cross paths with us at precisely the moment our instruments had grown powerful enough to study it? The timing seems impossible, but so does the fact that you are alive, listening now, on a planet that itself should never have emerged from dust. Or perhaps it is not a message at all, but a mirror. The wow signal and 3I, divided by Atlas, force us to reflect on our own hunger for meaning, on our need to believe the universe has intentions. In chasing these mysteries, we are really learning about ourselves, our patience, our humility, our willingness to wonder even when answers remain elusive. As you lie still, let the rhythm of your breath sync with the rhythm of time itself. Each inhale a present moment, each exhale a memory fading. Across decades, across light years, echoes weave themselves into stories, whether deliberate or accidental. They remind us that we are part of something vast and unfinished. The wow signal is gone. 3I divided by Atlas will soon depart. But together, they leave us with a resonance, like two bells struck far apart in time, yet ringing in harmony. That harmony does not prove intelligence, nor dismiss it. It simply exists an echo across time, waiting for us to listen. And perhaps, as sleep begins to draw near, you can imagine that somewhere in the galaxy, another listener is tracing the same echoes, wondering the same things, and waiting for their own wow. When you look up at the night sky in the warmth of summer, just above the horizon where the Milky Way spills its river of stars, you will find Sagittarius. To the ancient Greeks, it was no ordinary cluster of lights. They imagined a centaur, half man, half horse, raising a bow and drawing an arrow, aimed unerringly at the heart of the galaxy. The figure was both warrior and teacher, a paradox of wisdom and wildness, frozen forever in his cosmic stance. But for modern astronomers, the arrow points not toward myth, but toward one of the most extraordinary landscapes in existence, the galactic center. To peer into Sagittarius is to look straight into the crowded core of our Milky Way, where stars burn in densities we can hardly comprehend, where gas clouds swirl like storm fronts, and where a supermassive black hole, Sagittarius A times, anchors the orbits of hundreds of billions of suns. It is a place of extremes, beautiful, violent, and endlessly mysterious. Imagine standing in that stellar city. If you were near the galactic center, the sky would not be sprinkled with stars as ours is, but flooded with them. 1,000 suns would blaze where we see only a handful. Shadows would scarcely exist, the night lit brighter than our brightest desert skies. Planets would be tugged and jostled by passing neighbors, their orbits constantly perturbed. Radiation would rain from flares and collisions, making life at least as we know it difficult to imagine. And yet, what a vantage point it would be. From there, signals sent outward could travel to vast numbers of stars in every direction. Like a city square where voices can reach countless listeners at once, the galactic center offers a natural broadcasting hub. It is little wonder that SETI researchers have long regarded Sagittarius as one of the most logical places to expect a beacon. The wow signal appeared to come from this direction, and now, decades later, 3IATLAS traces its trajectory back toward the same broad patch of sky. Coincidence? Perhaps. But when we overlay human imagination on top of astrophysical reality, the symbolism deepens. Sagittarius is the archer, and twice now his arrow has found its way to our attention, once as a whisper, once as a wanderer. Even in antiquity, the constellation carried mystery. Babylonian stargazers saw it as the god Pabilsag, a figure of strange form with wings and a scorpion's tail. To them, Sagittarius was not just a hunter, but a guardian of thresholds, standing watch where the known met the unknown. How fitting, then, that this same region of the sky has delivered phenomena that guard their own secrets, daring us to cross into deeper understanding. There is something haunting about the galactic center. When Carl Jansky first detected radio waves from space in 1932, his instruments pointed towards Sagittarius. He had no idea what he had stumbled upon, only that a persistent hiss, repeating every 24 hours, came from that direction. That hiss was the voice of the galaxy's heart, speaking before we even had the words to understand it. Now, almost a century later, we still listen. The region teems with pulsars, ticking like celestial clocks, supernova remnants scattering their ashes, and star-forming nurseries, glowing with newborn light. To detect a mysterious radio signal here, or to trace the origin of an interstellar comet back to this direction, is both inevitable and profound. It is as though we are staring into a cosmic city of noise, and somehow two events manage to rise above the din, capturing our attention. But the mythology still matters. Stories help us feel what data alone cannot. Picture the centaur, muscles taut, arrow drawn. In the sky he is forever frozen at the moment before release, aiming into the dark unknown. Some myths say the arrow points at the heart of Scorpius, locked in eternal battle. Others say it aims at the very center of the Milky Way, striking at the mystery hidden there. Either way, the image is powerful, a signpost that humanity, across cultures and centuries, has read as a call to look deeper. Perhaps the wow, signal and 3IATLAS are not messages at all, but mirrors reflecting our own stories back at us. We see patterns, we see centaurs and arrows, because our minds cannot help but search for meaning. And maybe that is the real connection. Not that Sagittarius is sending us signals, but that it has always been the part of the sky where we project our most daring questions. Still, the coincidence lingers. The wow, signal, a 72-second burst. 3IATLAS, a comet with impossible chemistry, both from the Archer's direction. Is it truly random, or are we glimpsing the faint outline of something larger, some design beyond our comprehension? Speculative scenarios emerge when you let your mind wander. What if Sagittarius is not just the heart of our galaxy, but the lighthouse of many civilizations, a galactic bulletin board where messages are placed for anyone passing by? What if the arrow is not myth but metaphor, pointing us toward the realization that the universe is more interconnected than we dare to imagine. Or perhaps it is simpler. Perhaps the archer is not aiming outward, but inward, reminding us that the real mystery is not in distant stars, but in our own desire to search, to wonder, to interpret. Tonight, as your breathing slows and your eyes grow heavy, let the archer stand watch in your imagination. See his bow drawn, his gaze steady. Feel the tension of the string, the silence before release. Whether the arrow carries a message or only the weight of our curiosity, it reminds us that looking toward Sagittarius is looking into the heart of mystery itself. For it is there, in that crowded, radiant, turbulent part of the sky, that two of the greatest enigmas of modern astronomy have crossed our path. And it is there, perhaps, that when you look up from Earth, the Milky Way appears as a faint river of light, soft and serene. But follow that river toward Sagittarius, and you approach something altogether different, a city of stars. Here, at the galactic center, the calm surface of the night sky gives way to a storm of density, where stars crowd together like buildings in a metropolis, their light overlapping, their gravity weaving a ceaseless dance. To live in such a city would be unimaginable for us. Instead of a few dozen stars visible on a clear night, your sky would blaze with thousands, so bright you could read by their light. The night would never truly be dark. Every horizon would shimmer with suns, their warmth blending in ways that would make shadows alien and unfamiliar. And with every star comes the chance of planets, of worlds shaped by chemistries unlike our own. It is into this city, this chaotic heart of the galaxy, that our eyes turn when we speak of Sagittarius. It is here that the wow signals seem to whisper, and from here that 3IATLAS appears to journey. The galactic center is both paradise and peril. Its beauty is staggering, but so too is its violence. Radiation levels spike to punishing intensities. Magnetic fields twist with raw energy, and stars are born and destroyed in a cosmic heartbeat. At the core sits Sagittarius A*, a black hole with 4 million times the mass of our Sun, its gravity strong enough to bind this stellar city together. Around it, stars orbit at breakneck speeds, whipping around the abyss in cycles measured in mere years instead of millennia. Scientists watch those stars like detectives at a crime scene, measuring their paths to confirm the black hole's existence. But for our story, the symbolism is enough. This is the crossroads of the galaxy, the pulsing heart that both creates and consumes. To send a message from here, or to imagine an object ejected from here, feels fitting, as if the most crowded square of the cosmos were also its loudest stage. Yet amid this crowd, the problem becomes paradoxical. Noise overwhelms signal. It is like trying to hear a single conversation in Times Square at midnight on New Year's Eve. Pulsars tick, quasars roar, nebulae hum with the static of starbirth. And yet, in 1977, the wow signal managed to cut through. Its narrowness, its precision, stood out against the chaos, like a flute piercing through the roar of drums. That alone makes its origin uncanny. 3IATLAS too may have wandered from this metropolis. If so, it carries the chemistry of its birthplace, the unusual carbon dioxide dominance, the nickel without iron, as souvenirs from environments utterly unlike those in our calmer spiral arms. It may be a shard of a world destroyed in that crowded chaos, a fragment flung across light years until it brushed our solar system. There is something poetic in thinking of the galactic center as a city. Cities on Earth are places of chance encounters, where strangers brush shoulders, where signals are sent and missed, where noise and meaning intermingle. To live in a city is to accept both chaos and opportunity. And perhaps the same is true on a galactic scale. If civilizations arise, if they choose to announce themselves, The city of stars would be the perfect place to speak the highest balcony, the brightest square, the most visible stage. But here too lies danger. How do you find one deliberate voice among billions? How do you separate a message from the natural chorus of physics? The wow signal may have been one such voice, or it may have been the city itself, humming in a way we mistook for intention. Either possibility is humbling. Ancient cultures gazed at Sagittarius without knowing what lay beneath. To them, it was pattern and myth, a centaur drawing his bow. But they intuited something powerful, that this part of the sky mattered, that it pointed toward mysteries beyond. And so, in their stories, they placed figures of strength and wisdom to guard it. The archer stands there still, drawn against the skyline of eternity, aiming not just at the heart of Scorpius, but at the very mysteries we now uncover with telescopes and equations. Speculation stirs when we linger on this metaphor. What if the city of stars is not just a backdrop, but a gathering place? If civilizations exist, they may find the galactic center irresistible both for communication and for exploration. Its density means distances between stars are small. Imagine traveling not decades, but days between suns. Imagine signals leaping easily from system to system, forming networks of thought and exchange. If so, then perhaps what we see as chaos is, to them, an interconnected community, and perhaps the wow signal was a ripple from that community, reaching us across the quiet suburbs of the galaxy. Or maybe the city is indifferent. Maybe 3IATLAS is just a pebble tossed out from the busy streets, wandering far from home, and maybe that is wonder enough. To hold in our telescopes a fragment of a place we will never visit, but which nonetheless shapes our galaxy's destiny. As you breathe deeply, let yourself picture that city. Buildings of light, towers of flame, avenues of gas and dust glowing red and blue. Hear the hum of billions of stars overlapping, a cosmic orchestra so loud that only the rarest, most deliberate notes can rise above it. Into that orchestra, a single flute once played the wow signal. And into that city's silence, a wanderer once borne the comet we call 3IATLAS. The city is still there, vibrant and noisy, while we lie here, small beneath our quiet skies. But that is the wonder of it. Even from across 26,000 light-years, its echoes reach us. And whether they are voices or accidents, they remind us that we are part of something much greater. Tonight, as your eyelids grow heavy, let yourself drift into that thought. The city of stars is alive, its lights burning even now. Somewhere within it lies the answer to mysteries we have only begun to touch. Until then, we listen, we watch, and we wonder, citizens of a quieter suburb, gazing toward the galactic heart. Every comet tells a story, written in ice and dust. In our solar system, those stories tend to follow familiar scripts. Water vapor dominates, carrying with it traces of carbon dioxide, carbon monoxide, and other gases. When sunlight warms the nucleus, the frozen archives awaken, releasing plumes that form glowing comas and streaming tails. It is a pattern astronomers know well, a pattern written into textbooks and repeated across centuries of observation. But when 3IATLAS entered our sight, it refused to follow the rules. Instead of water leading the chorus, carbon dioxide emerged as the star. Measurements suggested a ratio of 8:1 CO2, vastly outnumbering H2O. This inversion is like hearing an orchestra where the violins have gone silent and the flutes play alone, louder than anyone expected. It is not impossible, but it is strange, as if the comet had been forged in a workshop where chemistry danced to a different rhythm. The James Webb Space Telescope confirmed it, its instruments tuned to the infrared glow of molecules escaping into space. Astronomers checked and rechecked, but the numbers remained. Carbon dioxide dominated. What kind of star system gives birth to such a body? Perhaps a hotter star, where water froze less easily. Perhaps a nursery cloud with unusual abundances, where carbon sculpted its own kingdom. Or perhaps something even stranger, something not yet in our catalogue of cosmic origins. Then came another contradiction. The comet was small. Hubble's best estimates suggested no more than 5 or 6 kilometers across, perhaps even less, some arguing as small as 300 meters. A cosmic pebble, really. And yet, despite its modest size, it produced a coma and tail far more vigorous than expected. It was, as astronomers delicately put it, overperforming. Think of a candle the size of your thumb producing the light of a bonfire. That was 3IATLAS tiny, but erupting with activity, as though eager to announce itself. Dust and gas poured into space, glowing against the sunlight, refusing to fade. It did not behave like the comets we know. It behaved like something else, something unwilling to fit into our categories. And then there was the nickel. Spectra revealed strong emission lines from nickel atoms, shimmering like metallic signatures in the glow of the coma. Nickel, in itself, is no mystery. It is often found in comets, released alongside iron as their metallic grains vaporize. But here, the iron was missing. Nickel without iron is like hearing one half of a duet, the other voice silent. It puzzled scientists deeply. Chemistry should not divide them so cleanly. Some suggested that perhaps the iron was still locked in minerals that required higher heat to free. Others wondered whether the comet's birthplace had favored nickel-rich minerals, leaving iron behind. Still others dared to ask if this oddity hinted at something non-natural, an engineered material perhaps, or a signature of processes unknown. None of these ideas satisfied fully. Each explanation felt like a puzzle piece pressed into place, but not quite fitting. It is in these contradictions that wonder lives. 3. I divided by Atlas is a mirror of our ignorance, reflecting how little we truly know about the diversity of worlds beyond our own. Perhaps our expectations, built on the small sample of local comets, are simply too narrow. Perhaps most interstellar wanderers are like this, and we are only beginning to glimpse their variety. Or perhaps 3. I divided by Atlas is unique, a singular messenger carrying chemistry from a star system whose rules are unlike ours. For those inclined toward speculation, these contradictions open doors. What if the dominance of carbon dioxide was not a quirk of nature, but the result of some long-lost process, industrial or intentional? What if the nickel signature, isolated and strange, was the fingerprint of alloys we do not yet understand? Could 3I divided by Atlas be more than rock and ice? Could it be a vessel, a shell, a disguise? Such thoughts tread the line between science and story, but they are whispers we cannot help but entertain. To ground ourselves, we remember, extraordinary claims require extraordinary evidence. So far, every anomaly has natural explanations, even if incomplete. Comets vary. Chemistry surprises. The universe is larger than our models, and yet there is something in the way these details cluster that makes it difficult to dismiss entirely. Just as the wow signal seemed too perfect to ignore, 3I divided by Atlas seems too contradictory to explain away without wonder. Imagine, if you will, the comet itself drifting through the dark, its nucleus black as coal, coated with ices older than our planet. The sun begins to warm it, and plumes erupt, gas and dust streaming like banners unfurling. But instead of water leading, carbon dioxide roars to life. Instead of the usual metals, nickel alone shines out. It is a comet, yes, but a comet of contradictions, a riddle written in stone and vapor. Astronomers track it night by night. Telescopes turn, cameras click, spectra form. Data pours in, numbers filling tables and graphs. But behind the analysis, behind the equations, is a sense of awe. Because this is not just a body from our solar system. It is a visitor from elsewhere, a fragment of an alien story. Its contradictions are not flaws, but clues, pointing to environments we cannot imagine, to histories we will never see. As you lie back, let your own breath become like the comet's outgassing, gentle, steady, releasing tension into the air. Each inhale is a gathering, each exhale a plume of release. The contradictions of 3IATLAS may never resolve fully, but they remind us that the universe is not bound to our expectations. It is freer, stranger, more creative than we dare to dream. And perhaps that is the lesson. To meet a comet of contradictions is to be reminded that life itself is full of paradox, fragile yet strong, fleeting yet timeless, small yet immense in its meaning. Just as 3IATLAS carries both mystery and clarity, so too do we. Tonight, as sleep draws closer, imagine that little nucleus sailing on its endless path, glowing briefly in the light of our sun before fading back into darkness. A contradiction, a visitor, a story unfinished. Every atom in the universe has a story. Hydrogen was born in the first seconds after the Big Bang. Carbon and oxygen were forged in the hearts of stars, scattered by supernovae to become the seeds of life. And nickel and iron, close cousins on the periodic table, are usually inseparable. They are produced side by side in the nuclear furnaces of massive stars. Their destinies entwined, like siblings. Wherever we find nickel, we expect to find iron. Together they form the backbone of planetary cores, the anchors of worlds. But in the case of 3IATLAS, the universe decided to break its own habit. Spectroscopic studies revealed nickel shining brightly in the comet's coma, its emission lines crisp and clear, and yet iron was nowhere to be found. The duet had become a solo, one voice missing, leaving astronomers puzzled. On Earth, nickel and iron are inseparable. They cool together in molten cores, they blend in meteorites, they appear side by side in the chemistry of comets. To see one without the other is like hearing the strings of a symphony but none of the brass. It is not impossible, but it is profoundly unusual. Scientists suggested cautious explanations. Perhaps the iron was still trapped in minerals that required greater heat to escape, while nickel, more volatile in certain compounds, sublimated more easily. Perhaps the comet's birthplace had favored nickel-rich minerals, a quirk of its parent star's chemistry. These were reasonable ideas, but none fully satisfied. Because in every case we know, iron eventually sings alongside nickel. Here, it remains silent. Think of a painter's palette, missing its expected colors. Imagine a painting of a forest where the green has been replaced with shades of silver. That is what 3IATLAS offered. A chemistry skewed, unbalanced, pointing toward an origin story unlike anything in our local catalogue. Was it forged around a different kind of star, one that left iron behind? Was it altered by galactic processes as it drifted through space for millions of years? Or was it something else, something not yet named? For those inclined toward imagination, the absence of iron becomes almost symbolic. Nickel is used on Earth, in alloys, in coins, in technologies that resist corrosion. To see nickel standing alone in the spectrum of a comet tempts us to wonder, could this be more than nature? Could it be engineered, a hint of intentional composition, like a fingerprint left behind? Most astronomers dismiss such speculation wisely, because natural explanations remain possible. And yet, the silence of iron lingers like a question unanswered. Let us pause to imagine the scene. In Chile, The very large telescope stares into the night sky, its mirrors gleaming under the southern stars. Astronomers huddle over screens, the data pouring in. A line at 341 nanometers, nickel. Another and another, but no corresponding iron. The graphs rise in puzzlement. A murmur passes through the room. They are witnessing something unprecedented. The comet, distant and faint, is telling them its secret, and the secret is strange. It is humbling to realize how much we infer from such whispers of light. A single line in a spectrum can overturn assumptions built over decades. Nickel without iron forces us to admit that our models are incomplete. The universe is not obliged to follow our rules. It writes its own, and we are the students, struggling to keep pace. And yet, in this puzzle lies beauty. To encounter the unexpected is to be reminded of how alive science, island, each contradiction is a doorway, each anomaly an invitation. 3I divided by Atlas is not just an object, it is a teacher. Its nickel lines are lessons written in starlight. Speculation abounds, as it always does when nature surprises us. Some imagine that the comet's birthplace was a system where metallic chemistry unfolded differently, where supernovae seeded elements in unusual ratios. Others suggest that long exposure to interstellar radiation stripped away iron-bearing compounds, leaving nickel as the survivor. And in the quiet corners of the internet, some whisper of possibilities more daring that the imbalance is artificial, the residue of an object not entirely natural. Whatever the truth, the absence of iron is not silence, but resonance. It is the universe telling us, once again, that we do not know as much as we think we do. Consider this metaphor. Nickel is the voice we heard, iron the voice we expected. Together they should have formed harmony, but instead we received a solo performance, haunting in its incompleteness. Sometimes beauty lies not in fullness, but in absence. Just as a pause in music can be more powerful than the note itself, so too can the missing iron make the nickel's song unforgettable. As you relax deeper into stillness, let this puzzle soothe rather than unsettle you. Imagine the comet drifting past, its coma glowing faintly, carrying within it the metals of forgotten stars. Nickel shines while iron sleeps, and we are left to wonder. Perhaps, in some faraway system, scientists are looking at fragments of our world and finding equally strange imbalances, wondering at our origins just as we wonder at theirs. Because that is what 3I divided by Atlas really offers us, a mirror. Its contradictions remind us that what we take for universal truths may only be local customs of our corner of the galaxy. Elsewhere, other rules may apply, other chemistries may dominate. In the end, nickel without iron is not an answer, but a question. And questions, more than answers, are what keep us awake, what keep us curious, and paradoxically, what lull us gently into sleep when framed as mysteries too large to solve tonight. So as you drift now, let your thoughts follow the faint metallic glimmers of 3I divided by Atlas, a comet of contradictions, a chemistry of imbalance, a reminder that the universe delights in surprising us. Somewhere in that imbalance lies a story we have yet to decipher, and perhaps one day, when another visitor arrives, its spectrum will sing the missing note, and the duet will at last be complete. In the theater of the cosmos, comets are usually modest actors. They are small bodies, icy and fragile, rarely more than a few kilometers across. When they near the sun, they put on brief performances, tails streaming, comas glowing before fading back into obscurity. Their shows are predictable, their brightness proportional to their size, their activity tied to their volume of frozen volatiles. But 3I, divided by Atlas, refused to stay within those expectations. Despite its tiny frame, perhaps no larger than 5 kilometers across, with some estimates shrinking it closer to a single city's width, it played a role far grander. It erupted with activity that seemed disproportionate, as though a child's voice had somehow filled an opera house. Astronomers call it an overperforming comet, a polite way of admitting they don't quite understand how it can do so much with so little. Its coma ballooned into a ghostly sphere, stretching hundreds of thousands of kilometers across, larger than the Earth itself. Its tail unfurled for millions of kilometers, curving gracefully under the pressure of solar wind and radiation. Every telescope that turned toward it saw a body defying its size, expelling more dust and gas than it should, burning brighter than the models predicted. Imagine lighting a candle and watching it flare like a bonfire, smoke billowing in impossible volume. That is what 3IATLAS seemed to do, take a small spark of sunlight and magnify it into a spectacle. The question, of course, is why. Some scientists suggest its surface is unusually rich in volatile ices, hidden reserves that erupt eagerly when warmed. Others argue its nucleus might be porous, riddled with fractures that increase surface area, allowing more gas to escape than a smooth object would permit. There are even whispers that its chemistry might involve compounds unknown to our solar system, reacting in ways we have never seen before. Each explanation is plausible, yet none feels complete. The comet continues to behave as if it has access to more energy, more material, more drive than it should. It is the overperforming wanderer, and its stage is our solar system. Speculation stretches further. If one allows imagination to wander, the comet could be something more than ice and rock. Perhaps it is hollow, its activity not just natural sublimation but something deliberate, venting, maneuvering, signaling. The mainstream consensus resists such leaps, and wisely so. But the mystery of 3IATLAS invites such thoughts. Its overperformance feels theatrical, as though it wants to be noticed. But even if it is only nature, the message is the same. The universe is not bound to our narrow expectations. It can create comets that sing louder than their size should allow, visitors that break our categories and remind us how little we know of other star systems. Picture the comet as it drifts inward. From afar, it is just a speck, indistinguishable from the countless rocks and ices drifting in space. But as it nears the sun, its true nature awakens. Gas begins to stream, forming a luminous halo. Dust scatters, trailing behind like a bridal veil, unfurling in the solar wind. To an observer with no instruments, it might look ordinary. But to astronomers, the data reveal excess, abundance, exaggeration. The comet is overperforming, refusing to fade quietly. There is something poetic in this. Many of us, in our own lives, feel small, insignificant, a single speck in a vast cosmos. And yet, sometimes, we shine brighter than our circumstances should allow. Sometimes, a small act, a single word, a single kindness reverberates larger than we ever intended. Perhaps 3IATLAS is the cosmic reminder of that truth, that small things can blaze with unexpected power. Astronomers debate in conferences and papers, trading theories, pointing to models, refining equations. But beneath the science lies a sense of awe. They are watching something never seen before, something that refuses to fit the script. In their charts and graphs, they are tracing not just numbers, but wonder itself. The overperformance has practical implications too. It means the comet can be studied more easily, its activity more visible, its chemistry more accessible. Its brightness, though modest compared to famous naked-eye comets, still allows instruments to gather far richer data than they could have from a dormant rock. The comet, in overperforming, becomes generous, a teacher eager to share its secrets, even as those secrets confound us. But let us not forget the larger context. This is not just a comet, not just a performer breaking the rules. It is an interstellar wanderer, carrying with it the heritage of another star. Its overperformance is not just spectacle, but a chance to peer into chemistry foreign to our solar system. Every molecule it releases is a clue, a syllable in a story written far away, long ago. And as it shines, we are reminded again of the coincidence or connection that ties it back to the WOW signal. Both anomalies, both from Sagittarius, both impossible to ignore. The signal spoke loudly for 72 seconds, then fell silent. The comet, small yet brilliant, continues to speak in gas and dust, its performance ongoing. As you lie back now, let yourself imagine drifting alongside 3I divided by Atlas. See its nucleus, dark and rough, spitting jets of gas into the void. Watch its tail bend gracefully, a shimmering ribbon against the black. Feel its overperformance not as anomaly, but as exuberance, the joy of being alive, the joy of existing against odds. Breathe in, breathe out. With each exhale, picture the comet releasing another plume, another whisper of its secrets. Small, yes, but mighty in its effect. Temporary, but unforgettable. 3I divided by Atlas is the overperforming wanderer, and perhaps so are we. Science thrives on repetition. A discovery confirmed once is only a curiosity. A discovery confirmed twice becomes a fact. We test, we retest, we watch the same patch of sky again and again until patterns emerge. But sometimes the universe resists. Sometimes it offers us a glimpse, a momentary flare of possibility, and then withdraws, leaving us to wonder if we imagined it at all. The WOW signal was one such moment. 72 seconds of perfection, narrowband, powerful, precisely at the hydrogen line, and then nothing. In the 48 years that followed, no telescope has ever heard its voice again. It was an unrepeatable whisper, spoken once and lost to silence. Imagine standing in a dark forest. You hear a single clear note, a whistle so pure it cuts through the night. You turn your head, strain your ears, but the sound never comes again. Was it real? Did you mishear? Was it a traveler passing by, leaving no trace? That is what astronomers felt when the WOW signal vanished. They pointed telescopes back at Sagittarius countless times. Big Ear itself scanned the region night after night. The very large array in New Mexico joined the hunt, its dishes swiveling in formation. Arecibo, the mighty dish in Puerto Rico, swept the skies with unmatched sensitivity. Australia's Parkes Observatory listened from the southern hemisphere. Decades of instruments, billions of seconds of attention, all met with silence. The WOW signal remained stubbornly unique. This unrepeatability became its weakness. Scientists who demand rigor grew skeptical. Without a second detection, how can we know it wasn't interference? How can we rule out an earthly origin, a glitch of equipment, a fleeting alignment of satellites? Some suggested mundane culprits, aircraft reflections, military transmissions, even a microwave oven leaking radio waves, but none fit the data cleanly. Others offered natural explanations. Perhaps it was a hydrogen maser flare, a cosmic radio laser triggered by some rare energetic event. That would explain the precision, the power, the transience. Yet no such flare has ever been observed to mimic the WOW signal so closely. It remains an outlier, even among exotic phenomena. And so it sits in a strange purgatory, not discredited, but not proven, too perfect to dismiss, too fragile to embrace. Yet maybe this is what gives the WOW signal its power. If it had repeated, if it had continued steadily, perhaps we would already have filed it into a category, natural or artificial. But because it did not, it remains suspended in mystery. It is a riddle with no answer, and therefore it endures. There is poetry in that. A single whisper can carry more weight than a chorus if it is the right whisper, spoken at the right time. Jerry Eamon's red ink "wow" was not just an annotation. It was the recognition of a moment that transcended data. A moment when the universe tilted slightly, and for 72 seconds, it felt as though someone, somewhere, was calling across the void. Consider how that whisper echoes across time. Nearly half a century later, we still talk about it, still listen for its twin. It has inspired generations of SETI researchers, fueled documentaries, novels, even music. The wow. Signal is not just an event, it is a story. And stories, unlike data, do not require repetition to survive. They live in memory, in imagination, in the human desire to find meaning in the silence. Still, the silence haunts. Why did it never come again? If it was intelligent, why speak once and vanish? Perhaps it was a mistake, a transmission aimed elsewhere that brushed us accidentally. Perhaps it was deliberate, a single test to see if anyone was listening. Or perhaps it was the last cry of a civilization now gone, extinguished before they could say more. There is a bitter sweetness in that thought. To imagine a world across the stars, sending one message into the dark, only for their voice to fade forever. And we, decades later, left holding only the faint echo of their existence. But perhaps the absence is itself the message. The silence that followed forces us to listen harder, to refine our instruments, to expand our patience. It teaches humility, reminding us that the universe owes us nothing. Not answers, not repetitions, not clarity. Sometimes it gives us riddles, and sometimes riddles are enough. Speculation blooms in the silence, as it always does. Some imagine the wow signal was not meant to be repeated, that it was a one-time beacon, a flare saying, "Look here," before something else, perhaps something material, would arrive. In this light, 3I, divided by Atlas, feels like a continuation, an echo, not in sound, but in stone. Two anomalies, decades apart, linked by their refusal to conform. Coincidence, perhaps, or choreography. Others argue the silence proves the opposite, that the signal was never intelligent, merely a natural flare we have not yet categorized. But even that conclusion leaves us with wonder, because if the wow signal was natural, it means the universe has phenomena we have never seen before, surprises still hidden in its depths. Either way, the mystery enriches us. As you breathe now, slow and deep, think of silence not as emptiness but as a canvas. On that canvas, the wow signal was a single brushstroke, bright, brief, unforgettable. The rest of the painting remains unfinished, and perhaps always will. But that is what makes it beautiful. In your mind, picture the printout, the neat rows of numbers and letters. Picture the circle in red ink, the word wow scribbled in astonishment. That circle is still there, preserved in archives, a relic of curiosity. It has not faded. It still speaks. And in that persistence, perhaps the signal has repeated after all, not in the sky but in us, in every researcher who turns a telescope toward Sagittarius, in every dreamer who looks up at the stars and wonders, in every listener, like you, lying quietly tonight, letting the possibility drift through your thoughts as sleep approaches. The wow signal was an unrepeatable whisper, but whispers linger, echoing in the chambers of memory, growing louder with time. Perhaps we will hear its twin one day. Or perhaps its gift was to show us that even a single moment of astonishment can last lifetimes. Either way, its silence has become part of its song. The wow signal has always tempted us toward extraordinary explanations, alien beacons, lost civilizations, messages across the void. But science, ever cautious, looks first to nature. And nature, it turns out, has its own way of creating radio light shows. These are called masers, natural cousins of lasers, but instead of light, they amplify radio waves. Maser stands for microwave amplification by stimulated emission of radiation. In simple terms, it happens when certain molecules, hydrogen, water, hydroxyl, are excited by energy from nearby stars or cosmic events. The molecules line up in a kind of quantum chorus, releasing radio waves all in step, focused, coherent, powerful. A maser can shine like a cosmic lighthouse, narrow and intense, its beam crossing light years. Hydrogen masers are especially intriguing because they sing at 1,420 MHz, the very frequency where the wow signal appeared. This is the hydrogen line, the natural calling card of the universe. If you wanted to build a message, you would choose this frequency, but so too does nature. The cosmos itself hums here, sometimes loudly, sometimes with bursts so intense they seem deliberate. The idea then is simple. Maybe the wow signal wasn't an alien hello, but a natural hydrogen maser caught at just the right angle, at just the right time. A coincidence? Yes, but the kind of coincidence the universe excels at. What would that mean? Picture a cloud of hydrogen floating in space, light years wide. A nearby magnetar flares, or a shock wave from a supernova passes through. The atoms inside the cloud are jolted into alignment, primed to release energy together. Suddenly, the cloud shines not in visible light, but in radio waves, focused at 1,420 MHz. For minutes or hours, it beams across the galaxy like a giant radio laser. If Earth happened to be in its path, if a telescope happened to be listening at that exact moment, the signal would arrive strong, narrow, unforgettable. And when the conditions faded, so too would the maser. No repeat, no pattern, just one miraculous alignment, never to occur again. This explanation gained traction in recent years, especially after reanalysis of the original data in 2024 and 2025. Subtle side patterns in the Big Ear archives suggested the wow signal might indeed have been embedded in a broader emission, exactly what one might expect from a maser's flickering pulse. Astronomers began to argue that the signal, while unusual, could still belong to nature's repertoire. Skeptics of alien hypotheses welcomed this. They reminded us that many cosmic discoveries once seemed artificial. Pulsars, when first detected, were so regular they were jokingly labeled LGM, little green men. Quasars blazed so bright they seemed impossible, until we learned about black holes. Fast radio bursts, too, were mysteries that flirted with extraterrestrial explanations before settling into astrophysical origins. Perhaps the wow signal is simply another such case. Nature surprising us until our understanding catches up. Yet even here, questions remain. If hydrogen masers can produce such signals, why don't we see more of them? Why has the wow signal remained so unique, unmatched by any other detection at that frequency? Astronomers admit this is troubling. For a maser to mimic the wow profile so perfectly its narrow bandwidth, its clean rise and fall requires conditions we have never definitively observed elsewhere. It would be a one-time alignment, a perfect storm, and so the maser explanation, while plausible, feels like a mirage. It satisfies, but only partly. It explains, but leaves us unsatisfied. It tells us, yes, nature could do this, but whispers, then why so rarely? Imagine standing in a desert, seeing water shimmer in the distance. The mirage looks real, convincing, but as you walk closer it fades. The maser hypothesis is like that. It offers a natural oasis for our skepticism, but when we try to drink from it, we find ourselves still thirsty for certainty. Perhaps the truth is that the wow signal was indeed a maser, but a rare one, so rare we may not see its like again for centuries. Or perhaps it was something else, something beyond both maser and machine, something we lack the language to describe. Still, there is comfort in the maser idea. It reminds us that the universe is capable of wonders that rival our imagination. We do not need aliens for the cosmos to astonish us. Hydrogen itself, the simplest atom, can orchestrate a performance so strange and beautiful that it fools us into thinking someone is speaking. That is worth marveling at. And there is humility too, in admitting that our instruments may have stumbled upon a phenomenon we do not yet fully understand. The wow signal becomes a lesson in patience, in caution, in the balance between wonder and rigor. As you breathe now, slowly, evenly, think of hydrogen atoms drifting in vast clouds, each one a tiny violin in an orchestra of trillions. Most of the time they play randomly, softly, their notes blending into background hum, but once, perhaps, they aligned in perfect harmony, sending their music across the stars. For 72 seconds, Earth heard that music. And then it was gone. Perhaps that is all it was. A maser mirage, fleeting but real, a natural wonder mistaken for a message. Or perhaps it was both nature's phenomenon, used or echoed by intelligence beyond. The line between natural and artificial is not always sharp. Sometimes, the universe leaves us suspended between categories, uncertain but enchanted. The wow signal remains, whether maser or message, a gift. It has sharpened our instruments, deepened our curiosity, inspired us to listen harder. It has become more than data. It has become story, myth, symbol. And in that sense, its unrepeatable whisper has repeated endlessly in our imagination. Tonight, as you drift towards sleep, let the maser mirage be a comfort. Whether it was physics or intelligence, the fact remains. The universe is capable of surprises that feel like contact, that sound like voices, that move us to wonder. And perhaps that is enough for now. The universe is vast, and most of it is silent. Yet now and then, humanity leans closer, cupping its ear against the stars, hoping to hear a whisper. With 3IATLAS drifting through our solar system, astronomers around the world recognized a rare opportunity. For the first time, an interstellar object would linger long enough, bright enough, close enough for us to aim our instruments with care. And so began one of the most ambitious listening campaigns in the history of SETI. Listening, here, is not metaphor. Giant dishes of steel and wire turned toward the heavens, their receivers cooled to near absolute zero, straining to capture faint radio waves from across space. Computers translated those signals into graphs and numbers, millions of data points per second. Somewhere in that ocean of static, perhaps, a message might lie waiting. The strategy was simple in principle, though daunting in practice. Listen everywhere, all the time. Telescopes scanned across the waterhole frequencies, the quiet band between 1,420 and 1,670 megahertz, where cosmic noise fades and hydrogen and hydroxyl molecules mark the universe's natural meeting place. It was here the wow signal once appeared, and here the hope was strongest. But astronomers did not stop there. They expanded the search across broader ranges, microwaves, millimeter waves, even optical bands where a pulsed laser might betray intelligence. If an alien probe were hidden within 3I divided by Atlas, it could use any frequency to speak. We had to be ready for all. The Breakthrough Listen project, funded by private initiative, dedicated thousands of hours of observing time. Its network spanned continents, the Green Bank Telescope in West Virginia, the Parkes dish in Australia, the Meerkat Array in South Africa. Each brought unique strengths, different sensitivities, different skies, different frequencies. Together, They wove a global net of vigilance. China's FAST, the world's largest single-dish radio telescope, joined in as well. Its enormous surface could gather faint whispers no other instrument might detect. Even NASA's Deep Space Network contributed when not busy speaking to spacecraft across the solar system. It was a symphony of cooperation, nations, and scientists, united by curiosity rather than competition. The listening campaign was timed with precision. Key moments were marked on calendars. The Mars flyby in October 2025, perihelion near the Sun at the end of that month, closest approach to Earth in December, the swing past Jupiter in March 2026. Each event offered a new geometry, a new chance. If 3I divided by Atlas were ever to transmit, these would be the moments: close passes, strong heating, encounters with magnetic fields. Some researchers whispered about trigger events, conditions that might awaken a probe if it were indeed artificial. Passing near a planet, feeling the tug of a giant's gravity, enduring the fire of perihelion, all might serve as activation codes. And so the telescopes waited, listening through the long nights. But listening is not passive. It requires patience, discipline, and the courage to face silence again and again. Hours of data rolled in, terabytes piling on servers. Algorithms sifted through the static, searching for narrowband tones, for unusual drifts, for patterns that could not be explained by satellites or natural sources. Every anomaly was flagged, double-checked, passed along for confirmation by independent observatories. False alarms came often. Airplanes, satellites, even microwave ovens could mimic cosmic signals. Each one had to be ruled out, carefully, methodically. This was not a hunt for quick answers, but for certainty. The stakes were too high for mistakes. And yet, even in the silence, there was beauty. The act of listening itself became profound. To aim a telescope at a visitor from another star, to monitor its passage with such care, was to declare something about humanity, that we are curious, that we are open, that we are willing to spend resources, not on conquest or profit, but on the fragile hope of connection. For the scientists who kept vigil, it was more than work. It was pilgrimage. Each night at the console, each graph scrolling across the screen, was a prayer of sorts, that the universe might answer, even faintly. Of course, skeptics abounded. Many expected nothing, and perhaps they were right. If 3I divided by Atlas was natural, it would pass in silence, a comet like any other. But even skeptics agreed the campaign had value. Every hour spent listening refined our techniques. Every null result tightened the boundaries of possibility. Even silence is information, telling us what is not there, guiding us toward what might be. And so, across the globe, humanity listened. From deserts and mountains, valleys and plains, dishes tilted skyward. Some pointed at night, others during the day. The Earth's rotation ensuring constant coverage. Data was shared, analyzed, archived, preserved for future eyes and algorithms. In a way, the campaign was less about finding signals than about proving we are capable of searching at all. Imagine, for a moment, lying beneath the stars as these telescopes do. Imagine extending your senses beyond your body, out into the cosmos, tuned to frequencies your ears can never hear. Imagine waiting, patiently, for a note that may never come. That is the act of listening on a cosmic scale. And perhaps the true wonder is that we do it at all. That in the middle of our noisy, crowded world, humanity still pauses to hear the silence between the stars. That in a universe billions of years old, we still dare to think that tonight might be the night we hear someone else breathing across the dark. The listening campaign continues even now, with no guarantee of success. Perhaps the data will reveal nothing. Perhaps, buried in the noise, there already lies a pattern waiting for a keener algorithm to uncover years from now. Either way, the effort itself is historic. For the first time, humanity has mounted a coordinated, multi-continent attempt to listen to an interstellar visitor, to treat it not only as rock and ice, but as a possible messenger. And if no message comes, then still, we will have proven that we are ready. That the next time a visitor arrives, or the next time a signal whispers, we will be listening with sharper ears, steadier patience, and deeper humility. As you rest now, let yourself drift into the rhythm of that listening. Picture the telescopes scattered across the earth, their dishes turning, their receivers humming softly. Feel the patience of scientists who keep vigil, hour after hour, year after year. They are listening not just for themselves, but for all of us. And in that act of listening, there is already connection, not with aliens, but with each other, with the universe, with the mystery of existence itself. When we focus on the details, the carbon dioxide ratios, the missing iron, the nickel lines, we risk missing the larger truth. 3I divided by Atlas is not just a puzzle of chemistry or physics. It is part of a much bigger story. Our awakening to the fact that the universe is alive with wanderers, and that each one carries a piece of a history not our own. For centuries, we believed the stars to be remote, untouchable, beyond any form of contact. Then we learned they hosted planets. Then we realized those planets might harbor life. And now, with the arrival of interstellar objects, we see that pieces of those other systems can travel here, across the darkness, to knock gently at our cosmic doorstep. 3I divided by Atlas is not an isolated curiosity. It is evidence that the galaxy is interconnected, that worlds do not remain bound forever to their birthplaces. Matter itself migrates, carrying stories across the void. The first visitor, Oumuamua in 2017, slipped past us almost before we knew it was there, fast, elongated, enigmatic, gone in a flash. The second, 2I, divided by Borisov in 2019, gave us a longer look, revealing chemistry forged around another Sunday. And now, 3I divided by Atlas, with its strange emissions and generous activity, offers months of observation. In less than a decade, humanity has gone from 0 to 3 interstellar guests. This is not chance. It is a sign of what lies ahead. Astronomers expect that as our telescopes improve, we will discover hundreds, even thousands more. The galaxy is filled with such wanderers, fragments of planets ejected long ago, comets expelled during the chaotic youth of alien systems. Our solar system itself has likely launched its share, shards of our world traveling now between the stars. The bigger picture, then, is not that 3I divided by Atlas is unique, but that it is a messenger of a new era. We are beginning to realize that the universe delivers samples to our doorstep, and all we must do is learn to catch them. This has profound implications for science. Interstellar objects are time capsules. Their compositions reflect the environments of their birth, chemical fingerprints from stars and systems unlike our own. By studying them, we can reconstruct the history of distant worlds without leaving home. They are like fossils carried across oceans, evidence of ecosystems long vanished but preserved in stone. The unusual chemistry of 3I divided by Atlas, far from being a problem, is a gift. Its dominance of carbon dioxide, its selective nickel emissions, its overperformance, these may all be signatures of conditions alien to our experience. Each anomaly is not a contradiction, but a clue. Together, they expand our sense of what planetary systems can be, what rules nature can bend when given enough stars and enough time. And beyond science lies philosophy. To know that fragments of other systems arrive here is to know we are not isolated. Our solar system is porous, connected, open to the wider galaxy. We are part of a network, even if unconscious, even if accidental. Matter migrates, stories travel, whispers cross the void. Perhaps life itself does too, carried in icy shells across light years, seeds waiting for fertile soil. Panspermia, once a fringe idea, gains new plausibility with each interstellar visitor. If comets and asteroids can cross from star to star, then so too can organic compounds, even microbes, shielded within rock. The ingredients of life might not be confined to one world or one system, but shared like gifts in a cosmic exchange. In this light, 3IATLAS is not just chemistry, it is potential, it is possibility. The bigger picture also forces us to confront humility. For all our technology, for all our progress, we remain beginners in this vast library. 3 interstellar visitors are not enough to define a pattern. They are barely enough to hint at one. We must listen longer, watch more carefully, build better instruments, and above all, remain patient. And patience is part of the lesson. The universe does not rush. It has had billions of years to scatter these wanderers. It will offer us more. The question is whether we are prepared to notice them, to study them, to learn. Consider, too, the human dimension. Across the world, professional astronomers and citizen scientists alike have turned their eyes toward 3I divided by Atlas. In backyards and observatories, in deserts and mountaintops, people are tracing its faint glow. In classrooms, students read about it, dream about it, ask questions their teachers cannot yet answer. This is science at its best, not confined to a laboratory, but shared, communal, inspiring. The bigger picture is not only cosmic, it is cultural. Each interstellar visitor reminds us of our shared curiosity, our shared home under the same sky. It binds us together in wonder, across nations and languages, as we ask the same question, what is this, and what does it mean? Perhaps the greatest gift of 3I divided by Atlas is not its data, but its timing. It arrives at a moment when humanity is divided in so many ways, distracted by crises, consumed by noise. And yet here is a reminder that above all our divisions, the universe still unfolds. Its mysteries remain, vast and patient, waiting for us to look up. The comet's coma, its tail, its anomalies, all of it is a quiet invitation to lift our gaze from the immediate to the infinite. As you breathe now, slowly, evenly, let this bigger picture settle in your mind. Imagine 3I divided by Atlas, not as an isolated anomaly, but as part of a great cosmic migration. Imagine countless other wanderers, each carrying fragments of alien worlds, passing silently through the gulfs of space. Some will come our way, some already have, and each one is a chance to listen, to learn, to expand our place in the story of the universe. Perhaps, one day, among these wanderers we will find not only chemistry, but company. Until then, each comet is a teacher, each signal a reminder, each anomaly a doorway. The bigger picture tells us that we are part of something immense, interconnected, alive with motion. And though our role is small, it is real. We are listeners, observers, participants in a cosmos that keeps offering us questions. And in those questions, perhaps, lies the greatest gift of all. There are moments in history that refuse to fade. A red pen circling a sequence of numbers in 1977. A whispered, "Wow!" written in the margin. A comet in 2017 that darted past before we understood it. Another in 2019, glowing faintly, but lingering longer. And now, 3I divided by Atlas, an overperforming wanderer, rich in contradictions, carrying chemistry not our own. Each of these moments is a reminder that the universe is still writing, still surprising, still whispering secrets into our ears. They may not always repeat, they may not always explain themselves, but they leave traces, and those traces become stories, guiding us forward. The wow signal was a spark, 72 seconds of possibility. It taught us to listen, to be ready, to take even a fleeting anomaly seriously. It has haunted us, inspired us, challenged us, and though it never came again, it set a standard. Extraordinary evidence demands extraordinary attention. 3I divided by Atlas is not a signal, but it carries the same weight of wonder. It does not whisper through radio waves, it shouts through chemistry and performance. A small body, overactive, unusual, arriving from the very direction where the wow signal once appeared. Coincidence? Perhaps. But coincidences have a way of changing us, even if they prove to be nothing more. Together, these two mysteries form a pair of questions suspended across decades. What spoke to us in 1977? What arrives to us now in 2025? The answers remain elusive, but maybe the point was never the answers. Maybe the point was the act of asking. For science is not built only on what we know, it is also built on what we dare to wonder. The wow signal and 3I divided by Atlas remind us that the unknown is not a void to fear, but a landscape to explore. They are milestones in humanity's slow transformation into a cosmic civilization, curious, listening, open to surprise. It is tempting to dream of contact, of deliberate messages, of probes disguised as comets, and perhaps one day such dreams will prove true. But even if they do not, even if these anomalies remain natural phenomena, they still give us something priceless: perspective. They show us that the universe is not static. It moves, it surprises, it sends wanderers and whispers to our doorstep. Picture the wow signal again. Rows of letters and numbers on a computer printout, a sudden spike, a circle in red ink. It was fragile, fleeting, unrepeatable, and yet it changed everything. Now picture 3I divided by Atlas. A faint point of light on a CCD image, a trajectory calculated, a coma blossoming as it nears the Sunday. It too is fragile, fleeting, destined to leave us forever. Yet it too changes everything. Neither one is proof of extraterrestrial intelligence. Both are proof of something greater, that the universe still has the power to astonish us. As 3I divided by Atlas rounds the sun and fades back into the dark, we are left not with conclusions, but with better questions. What other wanderers wait to be found? How many wow-like signals have slipped past unnoticed? How much of the universe's music have we missed because we were not yet listening? These questions, unanswered, are seeds. They will grow into new instruments, new surveys, new generations of curious minds. Waiting for the next wow does not mean waiting passively. It means building, listening, preparing. It means pointing telescopes at the sky, not just in search of certainty, but in honor of mystery. It means accepting that we may live our whole lives without proof. And yet our listening is still worthwhile, because in the act of listening, we declare something about ourselves, that we believe the universe may hold voices beyond our own, and that we are humble enough to hear them. And perhaps, when the next wow comes, whether tomorrow, in a decade, or in a century, we will be ready. Ready not just to detect, but to understand. Ready not just to speculate, but to confirm. Ready not just to wonder, but to connect. The future wow may come as a radio burst, a comet, a flash of light, or something beyond our imagination. Whatever its form, it will join the lineage of whispers and wanderers that began long before us and will continue long after. As you drift towards sleep now, let yourself rest in that possibility. The night sky above you is vast, filled with signals we cannot yet decode, filled with objects wandering unseen. Somewhere in that darkness, The next wow may already be on its way. Breathe deeply. Inhale the silence. Exhale the wonder. Feel the smallness of our world, and at the same time, feel its significance. We are listeners. We are storytellers. We are a species that can look at a fleeting anomaly and turn it into a legacy. The wow signal has not repeated. 3I divided by Atlas will not return. Yet their echoes linger, woven into the story of our awakening. They remind us that the universe is not finished with us. It still has surprises to offer, mysteries to unfold, connections to tempt us toward. And so we wait, not in despair, but in hope, not for certainty, but for wonder, not for answers, but for better questions. Waiting for the next wow is not a burden, it is a gift. Every visitor carries souvenirs of home. For humans, it might be a stone, a photograph, a word spoken in a familiar tongue. For interstellar wanderers, the souvenirs are chemical. Atoms and molecules arranged in patterns that whisper of their birthplaces. 3I, divided by Atlas, arrived with such gifts, and though they are faint, they are enough to remind us how diverse the universe truly island. Chemistry is the autobiography of matter. Each ratio, each emission line, each spectral fingerprint is a sentence in a story written billions of years ago. When astronomers pointed the James Webb Space Telescope and Hubble toward 3I divided by Atlas, they were not just measuring numbers. They were reading a memoir etched in ice and dust. The first lesson was inversion. In our solar system, water dominates comets, with carbon dioxide trailing behind. But 3I divided by Atlas reversed the order. Co2 outshining H. 208:1. This ratio defied the expectations built from decades of comet study. It was as if a familiar recipe had been baked with all the proportions: flipped bread made of sugar, soup made of salt. The taste was strange, but undeniably real. Why this inversion? Perhaps the comet formed closer to its parent star, where heat drove water away, but allowed carbon dioxide to freeze. Perhaps the star itself was different, hotter, richer in carbon, sculpting chemistry unlike our sun's. Or perhaps the interstellar medium it drifted through altered its stores, reshaping it slowly over eons. Whatever the reason, the lesson is clear. Not all planetary systems write the same recipes. The diversity of worlds is greater than we imagined. The second lesson was selectivity. Nickel without iron. Metals that should appear hand in hand instead arrived divided, one singing loudly, the other mute. This was not only an oddity, it was a revelation. It suggested that even basic assumptions, like which elements are bound together, may not hold everywhere. Planetary chemistry, it seems, is not a universal script, but a collection of dialects. Each system speaks its own version of the language of matter. Such discoveries expand our sense of possibility. If even comets can diverge so sharply, then exoplanets must be stranger still. Their atmospheres, their oceans, their soils could bear chemistries we cannot yet imagine. Life, if it exists there, may be written in elements combined in ways unfamiliar, yet no less real. The third lesson was exuberance. 3I divided by Atlas was small, yet it erupted with activity as though it were vast. It seemed to burn more brightly than its size allowed, releasing gas and dust at rates that puzzled astronomers. Its nucleus, tiny and dark, held more energy than expected. The chemistry inside was not only unusual, but vigorous, as though eager to announce itself. Perhaps its ices were unusually volatile, primed to sublimate at lower temperatures. Perhaps fractures in its surface multiplied the area exposed to sunlight. Or perhaps it carried hidden stores of compounds that ignited in ways our models do not predict. Whatever the case, the lesson was humility. The behavior of matter cannot always be anticipated by size alone. Even the smallest visitor can surprise us with a performance beyond proportion. Together, these lessons remind us that the universe is not uniform. It is varied, eccentric, creative. Every star system writes its own chemistry, and every interstellar object is a page torn from that book. When we read those pages, we glimpse worlds. We will never visit worlds with different suns, different atmospheres, different beginnings. This has implications far beyond comets. For exoplanet research, it suggests that when we finally detect the atmospheres of Earth-sized worlds, we must be prepared for surprises. Oxygen may not mean life. Methane may not mean decay. Ratios we think impossible may be normal elsewhere. 3. I divided by Atlas is the warning. Do not assume the universe shares your biases. There is also a quieter implication. If matter can migrate across the galaxy, carrying its chemistry intact, then perhaps so too can the ingredients of life. Amino acids, simple sugars, even fragile organics may travel within icy shells, preserved for millions of years between stars. 3. I, divided by Atlas, did not reveal such compounds, at least not yet, but the possibility lingers. The galaxy may not only trade rocks, it may trade seeds. Imagine the comet itself, a fragment of an alien recipe, drifting through space. For millions of years, it traveled in silence, untouched, unchanged. And then it entered our system, where light awakened it, where telescopes read its story. Its coma expanded, its tail unfurled, and in those luminous emissions, its autobiography was told. Not in words, but in ratios. Not in ink, but in spectra. As you breathe deeply now, think of your own body as a kind of chemistry lesson. The oxygen in your lungs was forged in ancient stars. The iron in your blood was born in a supernova. The calcium in your bones was crafted in dying suns. You too are an autobiography of matter, a traveler carrying the history of stars. In that sense, you and 3I divided by Atlas are kin. Both wanderers, both composed of stardust, both telling stories through the quiet language of chemistry. The comet teaches us that science is not about confirming expectations. It is about expanding them. It is not about finding sameness, but about discovering difference. Each anomaly, each contradiction, is not failure but revelation. 3I divided by Atlas will leave us soon, fading back into interstellar darkness, but its lessons will remain. In archives of spectra, in papers and debates, in the imagination of all who watched it. And when the next interstellar visitor arrives, those lessons will guide us. We will know to look for inversion, for selectivity, for exuberance. We will know to expect the unexpected. Tonight, as you drift toward rest, let this thought soothe you. The universe is a library, and each comet, each signal, each anomaly is a book. Some are long, some are short, some are confusing, some are clear, but all are worth reading. 3. I divided by Atlas was one such book, and its chemistry was its story. And in reading it, we have learned that the universe is more varied, more creative, and more alive than we ever dreamed. Life often forces us to ask, was that chance, or was it planned? We see patterns in clouds, meaning in numbers, connections in events separated by decades. Sometimes our minds mislead us. Other times, they reveal truths hidden in plain sight. In the case of the WOW, signal, and 3I divided by Atlas, the question is irresistible. Could two of the most unusual anomalies in modern astronomy, separated by nearly half a century, both emerge from the same constellation by coincidence alone? Or is there choreography in the cosmos, a dance we have only just begun to glimpse? Coincidence is the simplest explanation. Sagittarius is vast, sprawling across 30 degrees of sky, filled with stars, nebulae, pulsars, black holes. It is the galactic center, the busiest district of the Milky Way. If strange things are going to happen, it makes sense they would happen there. The WOW signal might have been a hydrogen maser flare, natural and transient. 3I/Atlas might be a comet ejected long ago, wandering by chance through our system. 2 unrelated mysteries, nothing more. The mathematics supports this. The sky is filled with billions of stars, with only one unexplained signal and 3 known interstellar visitors. Statistics cannot yet show patterns. To claim choreography from a sample so small is risky. Science, cautious by nature, leans toward coincidence. And yet, our intuition rebels. The WOW signal was too perfect, precisely at the hydrogen line, narrowband, intense, fleeting. 3I/Atlas is too contradictory, overperforming. Nickel without iron, carbon dioxide, outshining water, retrograde, yet nearly coplanar. Both arrive from Sagittarius. Both defy easy explanation. To call this mere chance feels unsatisfying, like dismissing a melody as random noise when its notes clearly form a tune. Perhaps what we are seeing is not chaos but choreography. Perhaps the WOW signal was the overture, and 3I/Atlas the encore. One, a whisper across radio space. The other, a physical messenger drifting into our view. Together, they could form the outline of a larger pattern, a pattern we cannot yet decode. Consider the metaphor of a stage. The galactic center is the brightest theater in the Milky Way, its lights dazzling, its audience vast. If a civilization wished to make itself known, to broadcast across thousands of stars at once, this is where it might stand. A signal from Sagittarius would be visible to many. A messenger from Sagittarius would be noticed by all who watch. Was it chance, then, that our instruments were listening in 1977, that our telescopes were watching in 2025? Or was it choreography, that in the brief span of human technological adolescence, we would be presented with 2 riddles, 2 invitations, pointing in the same direction? Skeptics remind us, extraordinary claims demand extraordinary evidence. Without repeat signals, without artificial signatures, without maneuvers beyond gravity, we cannot leap to conclusions. Coincidence is safer. Coincidence protects us from overreach, from seeing intention where none exists. But dreamers remind us, patterns matter. History is full of discoveries dismissed as coincidence until evidence accumulated. The alignment of continents once seemed meaningless until we learned of plate tectonics. The repeating oddities of planetary motion once baffled astronomers until Newton revealed gravity's choreography. Perhaps the WOW signal and 3I/Atlas are 2 notes in a symphony still unfolding. In truth, both views may be correct. To call them coincidence does not diminish their value. Coincidences can be powerful, shaping lives and sciences alike. To call them choreography does not mean we must leap to aliens. It may mean only that the galaxy has rhythms we do not yet understand, that Sagittarius is a hub of phenomena whose patterns will reveal themselves with time. Imagine lying beneath the night sky, tracing constellations. Sagittarius rises, its stars forming the archer's bow, pointing toward the galactic heart. Somewhere there, 48 years ago, a whisper called out. Somewhere there, today, a wanderer sails through our system. Coincidence or choreography, it hardly matters in the moment. What matters is that we noticed, that we circled the data in red ink, that we turned our telescopes to follow the light. And perhaps that is the deeper truth. Whether planned or random, Whether alien or natural, these anomalies serve the same purpose. They wake us up. They remind us that the universe is not static, not predictable, not fully charted. They remind us to stay curious, to keep listening, to prepare for the next surprise. Because one day, perhaps soon, another wow will come. Another visitor will appear. And when it does, we will be ready not just to record it, but to see it in the context of a pattern stretching across decades, perhaps even across civilizations. As you breathe now, let the question settle gently in your mind. Was it coincidence, or was it choreography? There may never be an answer. But the beauty lies in holding both possibilities at once, in letting the mystery be what it island. For in the end, whether by chance or by design, the universe has placed before us a pair of wonders, a whisper of radio, a wanderer of ice, both from Sagittarius, both unforgettable. The universe is always moving. Stars orbit, comets fall, galaxies collide, black holes merge in silent ripples. To us, these motions can feel distant, mechanical, indifferent, but sometimes an alignment occurs that feels almost personal. A signal once heard, a comet once seen, both from the same direction of sky. Whether coincidence or choreography, these moments draw us into the cosmic rhythm. They remind us that we are not outside observers, but participants in the dance. Humanity has always sought its place in this vastness. Ancient people built monuments aligned with the stars. They told stories of hunters, heroes, and animals written into constellations. The night sky was not decoration. It was a stage on which humanity found meaning. The centaur archer of Sagittarius, bow drawn toward the heart of the galaxy, is one such myth, carried across millennia. Today, our myths are written not in stone, but in data, in radio signals and cometary spectra. But the impulse is the same, to connect our small lives to the larger dance of the cosmos. The wow signal was one of those connections. It reminded us that even with primitive computers and a fixed metal trough in an Ohio field, we could touch something beyond ourselves. It was fragile, unrepeatable, but it showed that our instruments are capable of hearing whispers across interstellar space. 3I, divided by Atlas, continues that legacy. Its chemistry, its anomalies, its sheer strangeness remind us that the galaxy is not a static backdrop. It is alive, sending wanderers and wonders our way. To see both phenomena in the same region of sky ties them together in our imagination, if not in fact. They become not just separate mysteries, but a pair of notes in the same song. And by listening, by watching, we make ourselves part of that music. This is humanity's place, not to control the dance, but to join it. Not to demand answers, but to notice patterns. Not to be certain, but to be curious. We are a species that circles anomalies in red ink, that points telescopes at faint smudges of light, that builds enormous dishes to listen for whispers that may never come. These acts may seem small, but they are acts of participation. They are our way of stepping into the rhythm of the universe. And in doing so, we are changed. Once, we thought of ourselves as the center of all things. The sun circled Earth, the stars fixed in a perfect sphere. Then we learned we orbit a star among billions, in a galaxy among trillions. Humbling, yes, but also liberating. For if the universe is vast, then it is also rich. If we are small, then we are also rare, a species capable of listening, reflecting, wondering. Our place in the dance is not to lead, but to notice, not to dominate, but to belong. The wow, signal, and 3I divided by Atlas remind us of that. They show us that meaning arises not from certainty, but from openness, from allowing ourselves to be surprised, from accepting that sometimes the universe choreographs coincidences so strange that they feel like invitations. What do we do with such invitations? We listen, we watch, we prepare. The listening campaigns around 3IATLAS, divided by Atlas, the reanalyses of the wow signal. All of these are our responses. They are the steps we take to stay in rhythm with the cosmic dance. And in doing so, we declare something important about ourselves, that we are paying attention, that we care, that we wish to be part of the story, whatever it turns out to be. Consider how extraordinary this island. Across the world, in deserts and mountains, scientists huddle over screens, watching lines of data. Across cultures and nations, people tell each other the story of a signal and a comet, half a century apart, both from Sagittarius. Children hear it and ask if we are alone. Adults hear it and feel wonder stir again, despite the burdens of daily life. Humanity's place in the dance is not solitary, it is shared. We are all under the same sky, all part of the same question. And perhaps that is the most profound lesson. The universe may or may not be filled with other voices. The wow signal may or may not have been one. 3I divided by Atlas may or may not be a messenger, but regardless, they have already succeeded in connecting us to each other, to the stars, to our own sense of wonder. That connection is not coincidence. It is choreography we create by choosing to care. As you breathe now, slowly, deeply, imagine yourself in the dance. The earth spins beneath you, carrying you into night. The stars wheel overhead, bound by gravity's rhythm. Comets drift, signals whisper, galaxies turn. And in the midst of it all, you exist small, yes, but not insignificant. You are part of the pattern, part of the choreography, part of the song. Humanity's place in the dance is not to know everything, but to ask. Not to silence the mystery, but to live within it. The wow signal and 3I divided by Atlas are reminders that the universe is still speaking, even if in fragments, even if in riddles. And our role is to keep listening, to keep watching, to keep stepping into the rhythm. One day, the dance may reveal more. Another signal, repeating. Another visitor, stranger still. Another coincidence too perfect to dismiss. When that day comes, we will be ready. Not because we have mastered the cosmos, but because we have learned to join it, because we have learned that our place is not apart, but within. Until then, we wait, we listen, we wonder. And in doing so, we are already part of the dance. 3I divided by Atlas is not the first, and it will not be the last. Before it came, Oumuamua, in 2017, elongated, mysterious, gone before we could learn much. Then 2I divided by Borisov, in 2019, clearly a comet, familiar yet foreign. Now, in 2025, comes 3I, divided by Atlas, contradictory, overperforming, carrying puzzles in its chemistry. 3 messengers in less than a decade, after centuries with none at all. This is not luck, it is progress. Our instruments have sharpened, our eyes have widened, our patience has grown. The future will bring more. Astronomers predict that within the next few years, with surveys like the Vera Rubin Observatory's Legacy Survey of Space and Time, we may detect dozens, perhaps hundreds, of interstellar objects. What once seemed miraculous will become routine. And with each discovery, we will add another note to the cosmic symphony, another piece to the puzzle of how planetary systems form, evolve, and scatter their fragments into the dark. What will those visitors be like? Some will resemble comets, shedding tails as they warm in the Sunday. Some will resemble asteroids, silent and stony, passing without fanfare. Others may be stranger, still icy bodies with unfamiliar ratios, rocky shards with exotic minerals, perhaps even hollow shells of dust unlike anything we've seen. Each one will tell us something new about the diversity of worlds, The first lesson 3I divided by Atlas has given us is to expect the unexpected: nickel without iron, carbon dioxide more abundant than water, tiny size, great activity. If a single visitor can confound our models this thoroughly, imagine what 100 could do. Our understanding of planetary chemistry may change completely, our picture of the galaxy's diversity redrawn with every encounter. The second lesson is opportunity. With each visitor, we refine our ability to respond quickly. Oumuamua slipped past too fast. We barely glimpsed it. Borisov stayed longer, but we were unprepared to study it fully. 3I divided by Atlas has given us months, and with it, a chance to coordinate globally. By the time the next visitor arrives, we may be ready to do more than observe from afar. Missions are already being imagined. Spacecraft that could be launched rapidly to chase down an interstellar traveler, to fly alongside it, to sample its gases, or even return fragments to Earth. The European Space Agency has proposed projects. NASA has debated designs. Each interstellar object fuels the argument that we must be ready, because the chance may never come again. Once such a visitor leaves, it will never return. The third lesson is humility. Even with the best instruments, even with months of observation, 3I divided by Atlas has left us with more questions than answers. Its anomalies remain unresolved. Its chemistry resists explanation. Its origin remains uncertain. And that is the truth of exploration. Every discovery deepens the mystery. The next visitors will do the same. They will not provide closure. They will open new doors. But perhaps that is the point. Science is not a march toward final answers, but a dance of questions. Each interstellar object is an invitation to step further into that dance, to accept uncertainty not as failure, but as the essence of wonder. There is also the tantalizing possibility that one of these visitors will break the pattern entirely. That one day, a comet or asteroid will display not just unusual chemistry, but unmistakable signs of technology, controlled maneuvers, structured emissions, materials impossible to forge naturally. Most scientists consider this unlikely, but not impossible. And so, with every visitor, humanity listens not just for nature's secrets, but for hints of something more. Whether that day comes or not, the act of listening changes us. It builds a discipline of patience, a culture of wonder, a humility before the vastness of the cosmos. These qualities may be the greatest gifts the visitors bring. Imagine the future. Decades from now, dozens of interstellar wanderers have passed through. Our catalogues are filled with spectra, orbits, images. Some show chemistry like ours, others wildly different. Together, they map the diversity of planetary systems across the galaxy. The WOW signal is still remembered, but it is no longer alone. It has been joined by a chorus of data, anomalies, questions. Humanity has learned not only to watch, but to chase, not only to listen, but to answer. And maybe, someday, among those visitors, there will be one that does not leave, one that remains near, circling, waiting. Whether natural or artificial, it will change us again. As you breathe slowly, imagine yourself standing on a quiet hill, watching the night sky. Above you, comets and asteroids drift unseen, most too small to notice. Some bound to our sun, others bound to no star at all. At this very moment, future visitors are already on their way, crossing the dark gulf between stars. We do not know their names, their shapes, their chemistries, but we know they are coming. And when they arrive, we will be ready, eyes open, ears tuned, instruments steady. The universe is sending us books, and we are learning, finally, how to read. Toward future visitors, then, our role is clear: to stay curious, to stay humble, to prepare. The WOW signal may never repeat, 3. I, divided by Atlas, will never return. But they have taught us how to listen, how to notice, how to be awake. And that is how we will greet the next wanderer, with patience, with wonder, with the hope that each fragment of another world is also a fragment of our own story. The story ends where it began, in silence. Not the silence of absence, but the silence of vastness, of distance, of mystery. The wow. Signal came and went, 72 seconds of perfection, leaving behind decades of quiet, of 3. I, divided by Atlas, drifted through, glowing with contradictions, now fading back into the dark. Between them lies a span of nearly half a century, a human lifetime filled mostly with silence. And yet, that silence is not empty. It is the canvas on which all wonder is painted. Silence is the most honest part of the cosmos. Stars burn, comets flare, black holes roar, but between them stretches an ocean of quiet. In that quiet, radio waves travel, light ripples, signals pass unnoticed. Silence carries everything. It is not the absence of sound, but the medium of messages. Without it, we could not hear at all. When we complain that the wow signal never repeated, or that 3I divided by Atlas never spoke, we are really confronting the silence. But perhaps silence is not a failure. Perhaps it is an invitation. It teaches patience, humility, perspective. It reminds us that the universe does not owe us clarity. It offers whispers on its own terms, in its own time. Think of the silence after the wow signal. Telescopes turned back again and again, ears pressed to the sky, only to hear nothing. That nothing became as meaningful as the original whisper. The absence shaped our questions, inspired new technologies, created a legacy of listening. The silence was itself a teacher. Think of the silence after 3I, divided by Atlas. Telescopes gathered spectra, tracked its orbit, captured its glow, and now watch it depart. No message came, no signal, no proof of intelligence. But the silence it leaves is filled with wonder, with unanswered questions, with the knowledge that other wanderers will come. That silence, too, is a teacher. Silence has always been part of human stories. Monks seek it in cloisters, poets find it in pauses between words, musicians shape it into rhythm. In science, silence is data. In philosophy, silence is truth. In sleep, silence is comfort. And in the cosmos, silence is possibility, the infinite space into which meaning can be projected. The wow, signal, and 3I, divided by Atlas, are notes in that silence. Brief, bright, unforgettable. But the silence itself is the symphony, the vast stage on which those notes resound. Perhaps this is why these mysteries matter so much. They remind us not only of the strangeness of the universe, but of the power of not knowing. In our age of instant answers and constant noise, to be confronted with silence is rare and precious. It forces us to admit that we do not understand everything, that we are still apprentices in a vast and ancient school. And perhaps that is exactly what we need. Not proof, not certainty, not final answers, but mystery. Mystery keeps us listening. Mystery keeps us watching. Mystery keeps us awake. The future will bring more visitors, more signals, more anomalies. Some will prove natural. Some may remain unexplained. Perhaps one will prove, at last, to be deliberate. But regardless of outcome, the silence between them will continue, shaping our anticipation, deepening our humility. Silence is not a gap between discoveries. It is the space that gives discoveries their meaning. As you breathe slowly now, let yourself rest in that silence. Picture the night sky above you, stars scattered across blackness, each one distant, each one glowing into the quiet. Picture the faint trail of a comet fading into the dark, its chemistry dissolving into memory. Picture a radio telescope standing alone in a field, its dish tilted upward, waiting, waiting. Feel the calm of that waiting. Feel the beauty of not knowing. Feel the comfort of silence as something alive, something filled with potential. One day, perhaps, the silence will break again. Another wow, another wanderer, another coincidence, too strange to ignore. When it comes, it will not erase the silence. It will emerge from it, framed by it, made meaningful because of it. Until then, we live in the quiet, and the quiet is enough. Because in that quiet, we are already connected. To the stars, to each other, to the mystery of being alive in a universe vast beyond imagination. The wow. Signal has not repeated. 3IATLAS will never return, but the silence between the stars continues, carrying their echoes forward, carrying us along with them. And in that silence lies everything. Our questions, our hopes, our wonder, our dreams. Tonight, let that silence cradle you. Let it hold your thoughts as they drift. Let it soften the edges of your worries. Let it guide you gently into sleep. For the silence between the stars is not empty. It is full of possibility, full of mystery, full of the next wow waiting just beyond the horizon.